Hello, my name is Konstantinos Vythoulkas. I am a PhD candidate student with the University of Athens in Greece. The topic of this presentation is natural mixtures of palygorskite and smectite clay deposits from Grevena and Kozani, West Macedonia, Greece, and a comparison study with similar Spanish and Turkish clay deposits. The other co-authors is Mr. Stamatakis and Mrs. Argyrakis from University of Athens, and Mr. Manuel Pozo from University Autónoma de Madrid in Spain. It is an honor for us to present this study in this conference. To start off with, the objective of this study is to present the geological characteristics. These are these newly discovered palygorskite smectite clay deposits, as I said, in West Macedonia, Greece. They have been discovered approximately 25 years ago. Not a lot of literature for their geology, and they have been exploited since 2003, 2004, with the establishment of 4 mines in the area. One of these mines is the Pylori mine, where I'm showing you a picture of the palygorskite beds in gray. And in between the two, there's 2 palygorskite beds. You can see them in gray. They're in between smectite beds shown in green or greenish white. It becomes more white where carbonates dolomites are present. And to compare these newly discovered deposits with deposits from Spain and Turkey, a lot of people know them. In terms of mineralogy and chemical composition, very important aspects that define geological characteristics and the depositional environment. These deposits, as I said, are located in West Macedonia, northern Greece. Bottom left, you can see a map of Greece, and in yellow, the yellow box is the location of these deposits. From left to right is, you can see Arachi, Kanidi, Pylori, Harami, Velanida, where these palygorskite and clay deposits and mines occur. In yellow is the aerial extent of what we call the Vengia Basin. Vengia Basin is a continental rift basin that was formed during the Upper Pliocene, Lower Pleistocene, and from the shape of this basin, you can see that it looks like a fluvial lacustrine system. It's elongated. They give you some background information of these deposits. They are pretty large. Estimated reserves are over 20 million tons. They are natural mixtures of palygorskite and smectite. These deposits, and in particular palygorskite, was formed by in situ transformation of inherited smectites and possibly serpentine that originated from lateritic profiles of the ultra-basic rock. Some of the smectite came from smectite-bearing sands of the Tsottili Formation. The Tsottili Formation is part of the Mesohellenic Trough. It was formed during the Miocene and consists of marls and sandstones and conglomerates. There's a lot of mafic clasts in this formation. The smectite and palygorskite clays have a high iron and magnesium content, but low aluminum. Reflects the background of the ultra-basic rocks. Major mineral phases are palygorskite and smectite. The smectite, we assume that it's a mixture of mostly nontronite and saponite, and the other phases is serpentine, quartz, and dolomite. Now these are the major phases, but there are some minor phases that include sepulite, calcite, andesite, pyroxene, and magnesite. and trace phases. One can find maybe some chloride, talc, amphiboles, kaolinite, and illite. The SEM investigation revealed that most of this palygorskite fibers, laths, are normally very small and tightly interwoven. They form mats, but occasionally larger fibers occur that form skeletal structures. A method used is a detailed geological mapping and a lot of samples from exploratory boreholes and mine benches. These samples were analyzed with XRD, X-ray diffraction, on non-oriented samples, and oriented samples. We did some clay mineralogical studies, unglucolated heated samples. We used scanning electron microscopy with EDS and chemical composition on bulk analysis with ICP. From the bottom is the smectite phases. As I said, is the main mineral phase that was inherited in the basin, and this phase was evolved to palygorskite through mixed phases. You could see the fibers protruding from flakes, and where conditions were proper, the palygorskite was formed with typical laths at the top of the picture, SEM image, SEM. Now, the palygorskite from Spain and Turkey, we located some very good papers from Ms. Suarez. She did a review paper on palygorskites from Spain, and in particular, we studied palygorskite from Bersimwel, northeast of Madrid, and Tembelkuk, and from Turkey, we took papers from Yalcin and Bozkaya and Mr. Akbulut and Kadir from Hekeman region in East Turkey, near the city of Malatya, and in the Denizli region in southwest Turkey. Results based on this study comparison, the geological setting in Spain, the main bedrock is Arcosis, and the phases are distal phases from alluvial fans. That was the environment, the paleo environment. In Greece and Turkey is pretty similar. They're both ultra basic and basic rocks. In Greece, the palygorskite was formed in fluvial lacustrine environment, and in Turkey, it was formed in a shallow marine coastal lagoon. So it's a little bit different. Formation mechanisms are similar between Spain and Greece. Palygorskite was formed by syn or post-transformation dissolution of precursor minerals, but in Turkey, palygorskite was formed by direct precipitation from solution. The ages are almost the same between Spain and Turkey. They were formed in the Miocene or Upper Miocene for Turkey. In Greece, it's a lot newer. Palygorskite was formed well after that, during the Upper Pliocene, Lower Pleistocene. The accessory mineral assemblages, as a result, is a little bit different between Spain and Turkey. You can see that in Spain, the main mineral phases: quartz, gypsum, dolomite, calcite, feldspars, chloride or illite, smectite phases. In Greece and Turkey, almost the same composition: serpentine, dolomite, gypsum, and so on. Feldspars, chloride. But one can see here that there is no evaporite minerals in Greece, such as gypsum or celestite. And the chemical composition is almost the same between Greece and Turkey, with high magnesium and iron content. and low aluminum titanium, where on the other hand in Spain magnesium and iron is low, but silica and aluminum and sodium is high. And to conclude, this study aimed to present the geological characteristics, especially the mineralogy and the chemical composition of the Greek palygorskite clay deposit, and to compare these characteristics with palygorskite deposits from Spain and Turkey. Our results show similar geological settings and mineral assemblages between Greek and Turkish deposits, but different formation age. In Turkey, it's a little bit older. They were formed, as you might remember, the Upper Miocene, where the Greek deposits were formed during the Upper Pliocene. Spanish deposits have different characteristics altogether from Greek and Turkish deposits. Based on this study, we were able to explore differences in mineral and chemical composition, and this, as literature mentions, this can lead to different properties of palygorskite and industrial application. In addition, formation age can play an important role. As you might remember, palygorskite, the Greek palygorskite is small. The fibers are very small and tightly interwoven. Probably they didn't have a lot of time to develop. This affects the porosity, etc. Similar comparison studies between deposits from USA, classical deposit in Atabugos area, India, China, South Africa, Ukraine, can be very useful to explain formation mechanism and their role to industrial properties. Thank you. Thank you.